white paper is about enhancing security in Internet of Things environment by developing an authentication mechanism using CoAP protocol. Internet of Things has a high attention recently due to its new emergence benefits and contribution to improving the quality of human life. Securing IoT poses an open area of research as it is the base allowing people to use the technology and embrace this development in their daily activities. Authentication is one of the influencing security elements of information assurance, which includes confidentiality, integrity, and availability, non-repudiation, and authentication. Therefore, there is a need to enhance security in the current authentication mechanism. In this report, some of the authentication mechanisms proposed in recent years have presented and reviewed. Specifically, the study focuses on enhancement of security in CoAP protocol due to its reference to the characteristic of IoT devices, and it is need to enhance its security by the characteristic of IoT devices, and it is need to enhance its security by using the symmetric key with biometric feature in the authentication. This study will help in providing secure authentication technology for IoT data devices and users. The development of the Internet of Things technology and people's dependence on its many meters of their life requires securing it against any attack and revealing its vulnerability and amazing them. The first step of securing any technology is by conducting an conducting an effective authentication technique. Therefore, this study will review the existing authentication technique in IoT environment in order to propose a harder authentication technique. The main aim of this study is to propose a robust authentication technique for IoT environment, which ensures the security of IoT users, devices, and data. The proposed solution relies on using symmetric key with biometric feature. The object is to present some of the authentication mechanism proposed in recent years, enhancement of security in CoAP protocol due to its reference to the characteristic of IoT devices, proposing an authentication mechanism by using the symmetric key with biometric feature, executing an authentication mechanism and evaluated it to validate expected results. The benefit is to improving CoAP protocol, which is the most famous IoT protocol, providing a new method to combine using biometric feature with a symmetric key, proposing robust authentication technique that can improve IoT security, implementing the proposed technique to achieve security and performance goal, evaluating the proposed solution efficiency, and enhancing security of IoT users and CoAP protocol performance. Here we can see the block diagram of IoT network architecture, which represent the summary of the structure of the network in IoT, which has many application, transportation, smart home and cities, community and industry services, as well as a multiple users inter-system via the internet through the portal in which the user is authenticated, which is the first stage and essential part of the security in the Internet of Things. Thus, within this development and the large number of users, it has become a target for adversary, which record states and decision maker to put in place laws and legislation that protects everyone and deter everyone who takes an irregular way to achieve his goal. So after this introduction about authentication and elements, there is a review of the existing authentication mechanism, which was a multi-security method, like secure wallet, which change the password after every SASCA session. Also using user authentication key management protocol or multi-level trust-based intelligence schema, a novel lightweight block cyber-based multi-authentication protocol, efficient and secure three-party mutual authentication key argument protocol, a smart card-based secure authentication protocol, and multi-server secret blockchain, secure authentication schema using a hidden session key and block authorized access to the network, secure lightweight three-factor authentication schema using ban logic, a secure authentication, a protocol for 5G enabled IoT network, a three-factor anonymous user authentication schema, a dynamic authentication key argument schema, a smart contract based cross-domain authentication and key argument system, using a honey list, a privacy preserving authentication, authorization, and key argument schema via elliptical curve encryption, ECC, a security approach for CoAP based on Internet of Things, initialized TACACS plus. After this research, I choose the CoAP protocol, Constrained Application Protocol. CoAP is designed by the Internet Engineering Task Force by an idea of device-to-devices application, the cost-saving availability of restful resources allow power lossy network combined with the limited sophistication inform heat of protocol message decoding, asynchronous transfer framework, and built-in assist exploration render it's an optimal option for OAT deployers. Also support anycast and multicast demand by delivering user data protocol UDP and gives the ability to exchange a asynchronous message. Here we can see the format of CoAP protocol, which consists of 4 bytes in header. The first byte can be divided into 3 parts. The first 2 bits is for the version of the CoAP, and another 2 bits is for a type of message. We have 4 types of message in CoAP: conformable, non-conformable, and acknowledgement for conformable message, and a reset. The last 4 of the first bit is for token link. If there is any option or more of the header. Here code have another byte which is for request and response. Message ID, that the tool last for message ID for detecting the message duplication or for matching the response message, and there is a token or option or payload. Then we see here the component of CoAP protocol. We can see the CoAP transaction between two constrained devices, maybe between CoAP server and constrained devices. Also can be interact with HTTP server through proxy. So this is interact in IoT. Then we talk about CoAP protocol characteristic. It is created especially for constrained devices and their characteristics. It is assist monitoring and move of the block resources without refresh the entire data. Assist exploration of resources for consumer by using a URI pattern, dealing directly with HTTP like we said before. Also, most programming language like C#, JavaScript, and so on contain CoAP library, as well as for iOS and Android. CoAP has smaller process and capacity consuming, and it is easy to use. The drawback of the CoAP, which is doesn't include the trusted standard for secure structure, and its messages are secured on top of the UDP in the DTLS. That was not initially designed for resources limited devices, so it is not suitable for a CoAP agent. So when we talk about security CoAP protocol, there is with the DTLS, and like we say is not suitable for CoAP agent. Because not support multicasting like CoAP. Also, it need more transmission, 3 of DTLS and 1 for CoAP, which take more time. And a certain and aggressive isolate on battery operated system resources. Security in DTLS doesn't do well with the CoAP, so all messages need to be resent if one is lost. And because depend on UDP. Another security method is object security for constrained RESTful environment, which called OSCAR, is a new universal solution which offers cover-to-cover protection for CoAP transaction on the application layer. It's a good choice to security in CoAP protocol than DTLS. OSCAR's effectiveness at protecting and decoding message in superior to DTLS using HMAC and authenticated encryption associated data. So the research methodology is to propose security solution aims to authenticate IoT users using symmetric key with biometric feature. Biometric is a strong mechanism to authenticate user because it is a unique code. Symmetric key via AES 128 cm bits is a suitable state for security with a natural IoT constrained devices. when implementing CoAP protocol. This is the first figure can explain the research methodology. We can see here the client and the server. First step and first connect from client to server, their initial connect. Then the server requests a biometric feature and symmetric from the client. Then the client take a biometric feature, enter symmetric key, encrypt biometric with symmetric key. So server decrypt the biometric with the same symmetric key. We suppose there is known for all the symmetric key in client and server. If the symmetric key for the first time is true, then validate client and store the biometric. Then transfer application data. Here in another step, for another connect, client already know that is he have sent biometric encrypted with the symmetric key, and the server will validate the client if the biometric is true and symmetric before is true, and the biometric is stored there. Here the implementation, we implement with Python language. There are two main objectives that we are relied on when implementing the program. The first thing that is work based on CoAP protocol. Then the verification data, which is the fingerprint, I choose fingerprint, is encrypted with the symmetric key encryption algorithm, which is AES CCM. So here we can see the first photo, the main interface of the program that appears when the client's code is executed, where he can access by entering his biometric. Then another photo, the second screen, the client chose his fingerprints from the set of fingerprints defined in his database. Here we suppose this as it appears in the screen where the image is selected and then encoded with the encryption algorithm and sent to server. We can see there the CoAP server, like in the photo, have a unique message received. This is coming when the server decrypt the fingerprint. After he take the photo, you can here see the validate of the user and matching the fingerprint. Sorry. Also here we can see the sixth screen display linking client to one of the server related services, which is the camera. We suppose that is a simple IoT environment, which client connect to server to connect his devices, which is a camera, and can take a photo. So server give him this permission, and client can take a photo. Here we represent this photo as example. Analysis of the encoding CoAP protocol, enhancing CoAP protocol. So an authentication mechanism applied via CoAP protocol to prove the proposed solution has overcome some of the defects of CoAP protocol, as it is reliance on safety on DTLS is not suitable for restricted or constrained devices and cost more time. This leads to energy consumption and thus affects its effectiveness. The proposed solution is distinguished for OSCOR in that it relies on robust verification process, which is fingerprints, and therefore it can be said that the project have provided a good solution in this regard. So the future work. This study lays the foundation stone for the expansion of the more implementation of the authentication method based on CoAP protocol. The proposed solution can be improved by including all kinds of biometric features such as the iris, facial recognition, and retina. In addition, the extent of its effectiveness and security when it is actually implemented in the Internet of Things environment and linked to more than one devices and evaluated in terms of its effectiveness enhancing security of IoT's users. Here are the references of the presentation and the end if you have any question or comment. And so